So this video is going to be about the add instruction for the LC3. So the general format for the instruction is add destination register, source register 1, source register 2. So what's going on is it will take source register 1 and add it to source register 2, and then store it in our destination register. You can also use the syntax destination register, source register 1, intermediate value 5, and the 5 means 5 bits. So an example would be down here, we can take register 0 plus register 0 and store our result in register 0. If we want to use an intermediate value, we can use a pound or an X. The pound means to use decimal, so base 10, and the X means to use base 16. So we can do 5 plus R0 and store that in R0. We can do 10 plus R0 and store that in R0. So our encoding for this, you can see, is right here. So the destination and source register must be between 0 and 7. So R0, R1, 2, 3, 4, 5, 6, 7. And you can see this because if you look right here, our registers have 3 bits each. So it must be 0, 0, 0 to 1, 1, 1, which is 7. An important note to make, too, is that our intermediate value is signed. This means it only accepts between negative 16 and 15. So for instance, add R0, R0, pound 19 will not work because 19 is larger than 15. So changes that it makes is it sets the CC. So the code that is set is relative to the destination register. So if the result of R0 plus 5 is negative, the negative CC is set. If it's positive, the positive is set. And if it's 0, the 0 is set. All right, so let's look a little bit of code for this. So what I'm going to do is first I'm going to do add R0, R0, pound 15. So let's make a note. R0 is going to be starting at 0. So now when we do this, what we're doing is we're doing R0 plus 5. So our new result will be R0 equaling 5. If we want to, we can also do add R1, R0, pound 5. And this will be R0 plus 5. Our result will be R1 is equal to 10 because R0 is 5. R0 will stay the same though. We can also do add R0, R0, R1. And so when we do this, we'll be doing R0 plus R1. So if we take a look, R0 is 5, R1 is 10. So 5 plus 10 will mean that R0 will now equal 15. So we can also use, for intermediate value, hex. It's important to note that we can also use negatives. So if we do add R0, R0, pound, negative 15, it will be the same as saying R0 plus negative 15. This essentially means that it's subtracting. So if you think about R0 minus 15, they're the same thing. If we do this, R0 will now equals 0. So to use the hex, we just do add R0. Let's do it into R1. We'll do R0, X, negative, let's do 5. Okay, so R0, R1, so R1 plus negative 5. So currently R1 is at 10, minus 5 will mean that R1 will now equal 5. And R0 will stay at 0. So let's go up here and run it. So if we scroll up and we click load, all right, so currently our R0 is at 0 and R1 is at 0. So what we want to do is click, let me try a little bit. So we want to do, so we're going to do 5 plus R0. So 0 plus 5 is 5. So we click next, 5. All right, so into R1, we want to do 5 plus R0. R0 is currently 5 plus 5 means that R1 will now become 10. And there we go. All right, so R1 plus R0 and store into R1. So R1 is 5 plus R1 is 10, so that's 15. So 15 is going to be stored into R0. And there we can see that it worked. All right, so now we want to do R0, 15, minus 15, which will be 0, and then store that into R0. So if we click step, we can see that 15 minus 15, 0, so effectively cleared the register. So for the last one, we have add R1, pound negative 5. So in R1 we have 10, minus 5 means that the result will be 5 stored in R1. So if we click step, we can see that the result is 5.